Hey everyone, and welcome back for another deep dive. Today, we're going to be looking at, we're diving deep into the world of ultramagnetism.
Oh, yeah,
Have you ever heard of it?
I have.
Okay, cool.
Gross.
So this is going to be interesting because
Yeah.
it's not just a sciencey word. This is something that could potentially change the world as we know it. We could be talking, think about it, faster computers, phones that hold a charge for weeks, maybe even goodbye to those pesky energy bills.
Really?
Yeah, it's a big deal. We've got this article here, and they were so excited about it. Just reading it got me pumped up, too.
Well, it's not every day that a discovery comes along that has the potential to rewrite the textbooks.
Right,
But altermagnetism just might do that. What's so captivating is that for years, scientists believed there were only two main types of magnetism,
right,
ferromagnetism and antiferromagnetism.
right. And those are important for all sorts of things. I mean, ferromagnetism is why we can stick our kids' drawings on the fridge with magnets, right?
Exactly.
And antiferromagnetism, that's more about the atoms canceling each other out.
Exactly. But altermagnetism throws a curveball into the mix. It's similar to antiferromagnetism in the way its atoms line up, but here's the kicker. Its crystal structure has this unique quirk that lets it be both super stable, like antiferromagnetism,
Mm.
and have the storage capacity of ferromagnetism.
Yeah.
It's like getting the best of both worlds.
Okay, so we're talking about something truly unique, something that could shake things up big time. But how did we even find out about this ultramagnetism thing in the first place?
Well, the article highlights a team of researchers from the University of Nottingham, and they were examining a material called manganese telluride under a microscope. They were using some pretty high-tech tools like electron microscopy and X-rays to get a really close look at the structure.
So they're peering into this material, and bam, they stumble across this entirely new form of magnetism.
Yeah.
It almost feels like something out of a movie.
It's incredible, right? It was hiding in plain sight, in a material that scientists have been studying for ages. It makes you wonder what other mysteries are still waiting to be uncovered in the vast world of science. And speaking of mysteries, the article dives into something called the Einstein de Haas effect, which might be a key to understanding how altermagnetism works.
Einstein de Haas effect. Now that sounds pretty complicated. Break it down for us. What exactly is this effect, and how does it relate to this whole magnetism thing?
Well, imagine you have a spinning top. When you give it a push, it doesn't just move in one direction, it also starts to wobble or tilt. This wobble is due to the conservation of angular momentum, a fundamental principle in physics. The Einstein de Haas effect demonstrates a similar principle, but on an atomic scale. It shows that when you change the magnetization of an object, its atoms actually start to move or spin in response.
So it's like the atoms are doing a tiny dance when you mess with their magnetic field.
That's a great way to put it. And this effect, discovered way back in 1915, helps us understand that there's still so much we don't know about how magnetism works. At the most fundamental level, it suggests there are hidden connections between magnetism and atomic motion that we're only beginning to unravel.
That's pretty mind-blowing. So how does this Einstein de Haas effect tie into altermagnetism specifically?
Well, it suggests that altermagnetism isn't just about the arrangement of atoms, but also about how these atoms move and interact in response to magnetic fields. It opens up a whole new avenue of research, a deeper level of understanding that could lead to some truly groundbreaking applications.
And speaking of applications, the article gets pretty excited about the potential of altermagnetism to, well, to change the world as we know it.
And it's not just hype. We're talking about the possibility of computers that process information at warp speed, smartphones that stay charged for weeks, and even a complete transformation of how we generate and distribute electricity.
Okay, let's dive into these potential applications one by one. First up, the ultra-fast computers. What makes altermagnetism so promising for computing power?
Imagine a computer that could access and process data thousands of times faster than today's machines. That's the kind of leap we might be talking about. Altermagnetism could be the key to creating a new generation of memory devices that are not only lightning fast, but also incredibly energy efficient. Think about the implications for artificial intelligence, scientific simulations, and even just your everyday computer experience.
It would be like trading in your old bicycle for a supersonic jet. And then there's the dream of longer-lasting batteries, something we all wish for in our constantly connected world.
Absolutely. Imagine electric cars that can drive across the country on a single charge, or smartphones that only need to be plugged in once a month. Altermagnetism could be the game changer for battery technology, leading to batteries that are smaller, lighter, and far more powerful than anything we have today.
That would be revolutionary. No more range anxiety for electric car owners, and no more scrambling for a charger in the middle of the day. But the article also mentioned something that might be even more impactful: the possibility of lossless electricity transmission. Now, that sounds like something straight out of a science fiction novel.
It does, doesn't it? But it might actually be within reach. Think about how much energy is wasted right now during electricity transmission. Because of resistance in power lines, it's a huge amount. But with altermagnetism, we might be able to create materials that conduct electricity with almost zero resistance.
So we're talking about a world with dramatically lower energy bills, less reliance on fossil fuels, and a much cleaner energy grid overall.
Exactly. It's a vision of a more sustainable future. And altermagnetism could be a critical piece of the puzzle. But it's important to remember that we're still in the early stages of understanding this new form of magnetism. There's a lot more research to be done before we see these incredible applications become a reality.
It's almost like we've stumbled upon a treasure chest full of amazing possibilities, but we're still figuring out how to unlock it. So where do we go from here? What are the next steps in exploring the potential of altermagnetism?
Well, now that the scientific community is aware of altermagnetism, the race is on to understand its properties and how to control them. Scientists around the world will be conducting experiments, developing new materials, and pushing the boundaries of what's possible. It's a truly exciting time to be involved in this field.
It sounds like we're on the cusp of a scientific revolution. And it all started with some researchers taking a closer look at a seemingly ordinary material.
It's a great reminder that groundbreaking discoveries can come from unexpected places, and that curiosity and a willingness to challenge assumptions are at the heart of scientific progress. Who knows what other amazing secrets are waiting to be uncovered in the universe?
This whole journey into the world of altermagnetism has been incredible. It's made me realize just how much we still have to learn about the world around us. So before we wrap up, let's take a moment to recap everything we've learned about this fascinating discovery. We started by talking about the two well-known types of magnetism ferromagnetism and antiferromagnetism. We use these every day, whether it's sticking a note to the fridge or relying on the complex workings of our electronics. Then bam, enter altermagnetism. This newcomer breaks the mold, combining the stability of antiferromagnetism with the storage capacity of ferromagnetism. Thanks to its unique crystal structure, it's like finding a missing piece of a puzzle, one that could revolutionize everything from how we store data to how we power our homes.
Right.
We also dove into the mind-boggling world of the Einstein de Haas effect. This phenomenon shows us that messing with an object's magnetic field can actually make its atoms move or spin. It highlights the interconnectedness of magnetism and atomic motion, a concept that scientists are still unraveling over a century after its discovery. And let's not forget the potential applications of altermagnetism. We're talking about a future with blazing fast computers that can process information at unimaginable speeds, smartphones that stay powered for weeks on a single charge, and even the possibility of transmitting electricity without any energy loss.
It's important to acknowledge that these applications are still in the realm of possibility. We need more research, more experimentation, and a lot of brilliant minds working together to turn these dreams into reality. But the potential is undeniable.
This deep dive into altermagnetism has been a real eye-opener. It's a reminder that even in a field as seemingly well understood as magnetism, there are still groundbreaking discoveries waiting to be made. It makes you wonder what other scientific mysteries are out there, just waiting for someone to shine a light on them.
Exactly. And who knows, maybe one of our listeners will be the one to make the next big breakthrough.
Maybe so. So listeners, we want to hear from you. What are your thoughts on altermagnetism and its potential impact? What other scientific mysteries do you think are waiting to be solved? Head over to the comments section and share your thoughts. And don't forget to like and subscribe to The Deep Dive for more deep dives into the world of science, technology, and everything in between. We're always looking for new topics to explore, so if there's something you're curious about, let us know in the comments. Thanks for joining us, and until next time, keep those minds curious.